In order to see things in 3D, each eye must see a slightly different picture. The brain puts the two pictures together to form one 3D image. We often need to wear special glasses to be able to see 3D photographs or movies. The photo or the movie screen actually displays two images, and the glasses ensure that each eye only perceives the image that it is intended to see. Today, we use either passive glasses or active glasses. Passive glasses don't contain any active components. Active glasses, on the other hand, typically contain a battery-powered electronic device to alternately block the view of the left eye and the right eye. The first way to transfer different images into the left and right eyes of spectators in a cinema or auditorium is to put a so-called active polarizer in front of a projector. This is also called sequential stereo. The projector projects images for the left and right eye in sequence. The active polarizer changes the polarization of the light from vertical to horizontal in synchronization with the image content, making sure that the polarization for the left eye is perpendicular to the one for the right eye. The light is reflected by a screen that's coded to retain the polarization. Because the spectators are wearing passive 3D glasses with perpendicularly polarized lenses, they can see 3D images. For this system to work, the images need to be projected at double or triple speed because each eye needs to be fed enough images to get the impression of a smooth motion. This can only be achieved with DLP projectors. With dual projection, it's possible to omit the active polarizer. The images from each projector are destined for either the left or the right eye. In front of each projector lens, there's a linear or circular polarizer and, as in the previous setup, the polarization for the left eye is perpendicular to the one for the right eye. The images are simultaneously projected on the screen so they overlap, resulting in a blurry image. But since the spectators are also wearing passive 3D glasses with perpendicularly polarized coatings, they see clear and well-defined 3D images. Also here, the light is reflected by a screen that's coded to retain the polarization. Since this setup uses two projectors, the images can be projected at normal speed. The previous systems were based on the polarization of light. However, 3D projection can equally be based on the color of light. Color separation 3D works either with a dual projection setup or a single projector with a color separation wheel. The color separation 3D viewing system requires no special screen or wall to achieve a stereoscopic effect. This is an important consideration for cinema owners since special polarization-retaining projection screens tend to deteriorate the quality of 2D projections. This calls for some explanation. The visible color spectrum can be divided into red, green, and blue color tones. In the color separation 3D system, these color tones are split using a dedicated color filter wheel. Images for the left eye are recorded with slightly different red, green, and blue colors than images for the right eye. Both these images are projected simultaneously on the screen. Colored 3D glasses are used to filter out the exact image for each eye. The advantages of the color separation 3D system are that the images are clear, bright, and absolutely flicker-free. RGB laser projectors have the ability to use color separation-based 3D without the need for an additional color filter. This can be achieved by providing 6 primary colors, so-called 6P, as the light source, a set of RGB to generate the left eye image, and a second set for the right eye. When the lasers inside these sets have a slightly different wavelength than their equivalent color in the other set, the glasses can create the spatial separation and 3D effect. The last way to produce 3D is via the active system. With active 3D, the images are projected at double speed. A synchronizing device is installed in the auditorium to control the spectator's active glasses by means of infrared beams. Each time an image destined for the left eye is projected, the glasses completely block the lens in front of the right eye and vice versa. In this system, no special screen is needed.